Hello, students. An email asking a couple questions on 8.4, question 11, 12, and 17. All right, so for these, what you're looking for, at least for 11 and 12, is going to be you're finding the slope and then you're finding the equation. So maybe we'll tackle a couple of these, totally up to you. Now, notice some of them might be a little bit easier than others, just in terms of what they're looking for. So if you are busy looking and kind of saying, hey, what does this look like? When you see commonalities, you see kind of a pattern. Like, for example, here in B, what I can see is that the X term is exactly the same. So let me throw a little white space in here. Right. So when the X term is the same, all you're doing is changing the Y term. And remember that the slope is that change in Y values over the change in X values. Okay. Well, the Y values are changing. It really doesn't matter how much they're changing because the X value isn't changing. And so it doesn't matter what you have on top. You're going to have some number, but a number divided by 0 is undefined. So the slope here is just undefined. Then when it says write the equation of this, the equation would represent any point on the line. And what is the commonality? The commonality is that each one of the X values is -3. So the equation of the line would simply be that X is equal to -3. You can choose any Y value that you want. Now, if you chose to do this the way that I demonstrated in class, you're welcome to do that as well, but it will give you the same results. What you're looking at here is you're trying to see what is the change in Y values. And that one goes up by 117. Then the change in X values. Okay, so that one goes here to here, and that changes 0. So what you have is 117 over 0. That's your slope. Again, it's a number divided by 0, so it's undefined. Okay, and there you go. That's it for that one. Let's take a look at maybe another one. I'll do A, then I'll leave the other two for you to give it a shot. Let's see here. So again, just you can start the same way. -4, 1, 5, 2, and then you say, well, what is the change in Y values? The change in Y values is up 1. And here we go. The change in X values that went from -4 to +5, that is going up 9. So my slope is 1/9. So that's this part for question 11. Then it says write the equation of the line. So take the slope and pick any point you want. I'm going to pick this one, but it doesn't really matter. And put it into the equation. So in this case, we can write a slope-intercept equation as like y equals mx plus b. Put the m in, put the x and the y in, and let's see what remains. The y value is 2. The m value is 1/9. The x value is 5. And notice I am adding b at the end. So that's the one I don't know yet. So what I'm going to do is, multiply this out. And while I'm doing that, that of course will give me 5/9. I'm going to create a similar expression on the other side that has 9ths because the number 2 is really 18/9. And so we add b. Now I want to subtract something from both sides, and I'll subtract the 5/9 from both sides. So take that off both sides. And that leaves me with saying that 13 over 9 is b. So my final equation would be y equals 1/9 x plus 13/9. That would be my equation. If you'd like to check it, you can by plugging in the values of x and y and making sure that the statement is true. If you plug in -4 in for x, that gives you -4/9. When you add 13/9, takes away 4, and it gives you 9 over 9, which is the number 1. So that works. If you plug in 5 down here, you get 5/9 plus 13/9 gives me 18/9, which is the number 2. So they both check out. So that's kind of the approach to doing questions 11 and 12. All right. Let's see here. Oh yeah, there's a similar, like what I showed you for part B. If you look at part D, the X values change, but the Y value doesn't. If the Y value doesn't change, how could we do something similar to what I showed for part B? Remember that one, the equation was X equals -3. What will the equation look like now? Let me jump over here to number 17, which is one of the other questions that was asked. So, I have no idea which one you want me to do. What do I want to do? What do I want to do? Why don't I try the one that I think most of you probably go for, which is the one that has some fractions. So I'll do that one. Maybe I'll pick one other one. But again, the goal is to understand the idea. So write out your two equations, 3x minus 2y equals -1, and -3/2 x plus y equals 1/2. What I'm going to do is I'm going to multiply to clear all of my fractions out. The least common denominator that I could choose is the number 2. So I'm going to multiply everything by 2. So -3/2 times 2 gives you -3x. Y times 2 becomes 2y, and 1/2 times 2 becomes 1. So I have that, and all I'm going to do is bring down the top equation and rewrite that one as 3x minus 2y equals -1. Now what I can see is these line up perfectly, so I could eliminate them by combining like terms. -3x plus 3x gives me 0. Boom. And plus 2y minus 2y, that would be a plus 0. And 1 minus 1 gives me a 0. And now take a look at this statement. The lines that we saw up top, those two lines will intersect. These lines right here intersect when 0 plus 0 equals 0. Yeah. Okay. Well, when does 0 plus 0 equal 0? And you would say always. It always works. What does that mean about this? That means the lines intersect always. And if they always intersect, then there must be infinitely many solutions. Okay. Now, if you want to find what do those solutions look like, they actually look like either one of the lines, because as it turns out, the lines are exactly the same equation. So that is how we would represent that piece, infinitely many solutions. All right, not too bad. Let's try another one here. Okay. So let's try, you want to take your pick? Since nobody's here, I'll just pretend that I'm talking to somebody. There we go. Why don't we try, maybe we'll try this one, right? Maybe we'll try part A. Again, there's nothing, you could pick any of them, but again, you're trying to, in my mind, the elimination is kind of the best. So think about kind of how you would eliminate things. I mean, I would look at C, but if you just rewrite C, the first one would be minus x plus 2, and the next one would be y equals x minus 2. So if you just add those together, I think you'll be on your way to a solution pretty quickly. This one does require a little bit more. So you do have to, let's just do what we did before. We write out our equations. I almost said expressions. And I have 3x minus 9y equals 10. Okay. Now, what's your goal? Your goal is to eliminate one of the variables. So you can pick which one. You want to get rid of x, you want to get rid of y. Doesn't matter to me. Let's say you want to get rid of x. Then I need a common multiple of 2 and 3 so that when I multiply the top equation by a number and the bottom equation by a perhaps different number, I will end up with the same values for x. So for the coefficient on x. So 2 and 3, their least common multiple is 6. So in order to get a 6, I would multiply the top one by 3. And just so later I can actually do addition, I'm going to multiply the bottom one by -2. Okay, so let's see here. -2 will go right there. -2 times 3 would be -6x. -2 here would be plus 18y equals -20. All right. Now bring this one down, multiply by 3. So I end up with 6x minus 18y equals 21. And now we will add those together. -6 plus 6 gives you 0. Positive 18y minus 18y is 0. And -20 plus 21 is the number 1. So again, what are we saying? The two lines up here, they will intersect when 0 plus 0 equals 1. When does that happen? And hopefully you look at that and you say never, which means there is no solution. And whenever you graph two lines and there is no solution, you would say the lines are parallel. All right. So there we go. Let me do one more because these seem to kind of eliminate pretty quickly, and you should be able to handle any equations that are thrown at you. So why don't I'll toss a little bit of white space in here. We'll do one more together and make sure we feel comfortable with those type of equations. For this one, I am just going to make numbers up. And the reason I do this is most of the time when you make numbers up, you get something that doesn't eliminate really easily or quickly. So I'm going to choose 3x minus 4y equals 11. And then down below, I'm going to choose 5x plus, what do I want to say? Maybe 7? 7y equals 20. Yeah, for no reason. Okay, there we go. There we go. Here's a new one. So let's try this together. Let's say we want to eliminate something. I can look right here. The y values, one's positive, one's negative. Let's get rid of the y values. So what I'm going to do is I'm going to multiply, put this line down the middle, multiply the top one by, I want to get rid of y, so I'm going to multiply by 7. Because 7 times 4 gives me 28. And I'm going to multiply the bottom one by 4, because 7 times 4 is 28. Okay, let's see what that looks like. Oh, I should change the color just so we don't mix them up. Okay, 5 times 4 is 20x's. 4 times 7 is 28y. And 4 times 20 is 80. Next up, let's see here. We'll bring this one down. 7 times x is, or 7 times 3, I guess I should say, is 21x's. 7 times 4 is minus 28y. And 7 times 11 is 77. Right? Awesome. So now all I need to do is get rid, if I add these together, the y values are going to eliminate completely. And that leaves me with 41x's equals 157. All right. So x is 157 over 41. So again, what are we saying? These lines will intersect when x is equal to 157 over 41. Now, again, that's just the x coordinate. If you want to find the y coordinate, you need to plug this in. And I'm just going to tell you plugging this into either one of these equations is going to be a bit of work. You're going to have to multiply or by positive or negative, then bring it to the other side, then get a common denominator, then divide or multiply. And it creates a lot of areas where you could make a mistake. So what I tend to do in these situations is I go back to the original problem, and then actually I'll just use the same color. And then I'll write the original problem down. And instead of eliminating the y values like we did at first, I'm going to eliminate the x values. So I'm going to look at this top one. I need to eliminate x's, which means I need to multiply the top one by 5. And you know what? I'm going to do -5 here because that'll give me a -15. And then for the bottom one, I'm going to multiply by 3. Okay, so let's do the 3 one here. So 3 times 5 is 15x. 3 times 7 is 21y. And 3 times 20 is 60. And let's bring the other one down. Here we go. -5 times 3 is -15x. Negative times negative is a positive 20y, and negative 5 times 11 is negative 55. Okay. Let's bring them all together. When I add these together, the 15 and the negative 15 go away. 21 and 20 gives me 41y, and that equals 5. So y is equal to 5 over 41. So what you do is you kind of say, well, actually now I know where these lines intersect, and they intersect at 157/41. That's the x coordinate, and 5 over 41, that's the y coordinate. So there you go. Now, if I were you, I would want to check this, okay? So let's see here. Let me jump up here to Desmos. Okay, and so I am going to, let me just jot this down. Oops, okay, I get rid of that. I really just want this chunk right here. Okay, so I'm just gonna drag that up over here. And then the rest of it, I'll just get rid of. Okay. Woo, there it all goes. All right. And maybe I'll leave those first two up there as well, so we can actually type those in and kind of see the result if you want to kind of check yourself. Okay, so I will leave those as well. And we'll just kind of swing those. I'm not sure if I can. I hope so. No, that just makes them bigger. Okay, I'll just drag them over to the side. All right, let's take a look at this. We're going to come down here to the graphing calculator and just kind of say what are we looking at here. So what I'm going to do is I'm going to take these equations and I'm going to plug them in right here. And I'm going to show you kind of a shortcut that I think works really nicely for using Desmos. I'm just going to say my first value is A, and that's 157 over 41. Okay, my second value is B, and that's 5 over 41. Okay, there's A and there's B. And I'm not sure why I'm zoomed in so darn much, but let's see if I can bring it back just a little bit. There we go. 157, 45 over 40. Now, see your equation right here? Just write it out. I have 3 of the A things minus 4 of the B things. And 3A minus 4B gives me 11, and that's what I should get. Now the other one gives me 5 A's plus 7 B's, and I get 20. So yeah, it checks out perfect. You could also type the entire equation out. Again, I like this one because it lets me do both checks pretty quickly. Okay. Let's see here. If you had your handheld calculator, yeah, just type in 3 times 157 over 41 and end parentheses minus 4 times 5 over 41. Just put that in your calculator. When you hit enter, you should get 11. Okay, so there we go. So now here comes the fun. What I'm going to do is this. I'm going to change this to say 3x minus 4y equals 11. That is a line. The next one is going to be 3x plus 7y, and that has to equal 20. That is a different line. But if I zoom in here, I can see those two lines intersect, and they intersect at 3.829, which again is 157 over 41, and 0.122, which again is 5 over 41. So you can actually see the A value is here, the B value is right next to it, and that's a good way to kind of check yourself visually if you're able to use this kind of tool. All right, so I think that does it. I gave you a few different pieces. Sometimes they intersect at 1, sometimes they intersect at all, and sometimes they intersect at none. You should be able to handle all 3 of those types. All right, off you go.